right. So we're back for another deep dive. And today, we're going deep on entangled.
Sounds exciting.
Yeah, it's a listener-suggested concept.
Oh, yeah.
And it really caught our attention. So,
Yeah.
I mean, what if you could actually, control quantum entanglement and, use that to generate energy?
Create power. That'd be amazing.
That's entangled.
Very cool.
So, lucky for us, we have, the perfect person to help us break this down.
Well, I'm happy to be here.
So, entanglement.
Okay, so
we got to start there.
Entanglement.
What is that?
So it's this idea in quantum mechanics that you can have these two particles and they're linked in a way that even if you separate them by a huge distance, what you do to one instantly affects the other.
That's so weird.
It is. It's really bizarre, but it's been experimentally verified. So
okay, so it's a real thing.
It's a real thing, yeah.
Okay, but how do we get from freaky action at a distance to powering our houses?
Okay, so this is where the concept of force barriers comes in.
Okay.
So imagine you have these two entangled particles.
Okay.
And they kind of want to be in a specific state, a low energy state, because they're linked.
Right.
So now, what if we introduce a barrier that prevents them from reaching that state?
So we're messing with them?
Yeah, we're kind of forcing them to stay in this higher energy configuration.
And that's where the energy comes from.
Exactly.
Okay, so how do I...
So in the quantum world, energy levels are quantized. So it's not like they can just gradually lose energy. It's like steps on a ladder.
Okay.
They have to jump down from one step to another.
Got it.
And when they make that jump, that's when energy is released.
That we can use.
Potentially, yes.
Yeah. Okay, so instead of just watching entanglement happen,
we're manipulating it.
We're tweaking it.
Exactly.
To get energy out of it?
Yeah, we're trying to control it.
Okay, so what kind of...
And extract energy from it.
Yeah.
What kind of force barriers are we talking about here?
So that really depends on the type of particles we're working with.
Yeah.
One example, if we're using charged particles...
Like ions.
Like ions, exactly. We could use electromagnetic fields.
Okay. Like magnets?
Kind of like magnets, yeah.
Yeah.
But we need to very carefully control these fields.
Okay.
So that
keep them.
We can hold the ions in this high energy state without completely breaking the entanglement.
Right. So it's we're pushing on them.
Yeah. It's a delicate...
But not too hard.
Balance.
Yeah. So how do we even...
It really
entangle particles in the first place?
Oh, there are a bunch of different techniques.
One common method is using lasers.
Okay.
To excite atoms and create entangled photon pairs.
So we can use lasers to
Yeah, they can play a role
entanglement
in both creating and maintaining...
The force field.
Yeah, the force barrier.
Or force barrier, yeah.
The key is precision.
Okay.
We need to be really careful.
So this is super complicated.
Yeah.
What are some of the big...
It's a very delicate process.
Yeah, what are the big challenges?
One of the biggest challenges is maintaining quantum coherence.
Okay.
Which is essential for entanglement to persist. The real world is messy.
Yeah.
There's heat, there's vibrations, stray electromagnetic fields.
And all that can mess it up.
All of that can disrupt the quantum system.
So even a little bit of noise.
Yeah. Even a tiny disturbance.
Make it all fall apart.
Can cause decoherence.
Yeah.
Where the particles lose their entanglement.
And then we don't get energy.
And then we can extract the energy.
Right. And it's not just keeping it.
Exactly. It's not just that. We also have to figure out how to efficiently convert that quantum energy.
Into something useful.
Into a usable form, like electricity.
Yeah.
We need a bridge between the quantum realm and our everyday world.
Yeah, so it's we got to control it.
Exactly.
On the tiny level.
Yeah, we have to control the particles at the quantum level.
And then also...
But then also figure out...
Bring it up to our level.
How to get that energy out into something we can use.
Okay, so assuming...
That's a big challenge.
Yeah, assuming we can do all that.
Yeah.
What would be
What's the payoff?
The benefits of entanglement?
Well, the potential benefits are huge.
Okay.
Imagine a world where energy is basically limitless. And clean.
No more pollution.
Environmentally friendly,
That would be amazing.
It would revolutionize everything.
So we've got this basic framework, right?
Yeah, we've got the basic idea.
Entangle particles, push them.
Create the barrier.
With a force barrier.
Force them into a higher energy state. and then extract the energy.
When they fall back down.
When they transition back down.
But let's get into like...
Yeah, let's dive a little deeper.
The nitty-gritty.
Into the details.
Like what kind of particles could we actually use?
Right, what are the options?
And how do we build these force barriers?
Yeah, how do we actually make this work?
And how do we get the energy out?
What does the extraction process look like?
So let's talk about all that.
Let's get into it.
After the break.
Sounds good. Okay, so when we're talking about entangled and like what kind of particles we could use.
Yeah, like what are we actually going to use for this?
Well, one really promising option is ions.
Ions?
Yeah, they're charged atoms.
Okay.
And they offer this good balance of, we can control them.
Mm-hmm.
And they have a lot of energy potential.
Okay, and we were talking before about using like electromagnetic fields.
Right, like as those force barriers.
Yeah, to keep them energized. Can you like...
Yeah, so break that down a little.
Okay, so we have this cloud of ions, right?
Okay.
And we've carefully like prepped them to be in this superposition of states.
Yeah.
And then we use these electromagnetic fields, but they're really precisely tuned to create this barrier.
Mm-hmm.
And it's a potential energy barrier that stops the ions from just settling into their like preferred entangled configuration.
So it's like we're using these fields to kind of like...
Yeah, it's like these invisible walls.
Push on them?
Yeah, that's a good way to think about it.
Yeah.
We're confining them.
To keep them.
And keeping them in this high energy state.
Mm-hmm.
It's a very delicate balance though.
Okay.
It's like, walking a tightrope.
Right.
If the fields are too weak, the ions are going to, they're going to escape.
They're going to overcome the barrier.
Yeah.
And just entangle like they normally would.
And if it's too strong.
Well, if it's too strong, then we risk totally messing up the superposition.
Oh, so it's like...
causing what we call decoherence.
We got to get it just right.
Yeah, it's a very fine line we have to walk.
Okay, so we've got our ions. They're trapped.
They're trapped. They're energized.
They're energized. How do we actually...
Okay, now the next question is...
get the energy out.
How do we get the energy out? And this is where things get really tricky.
Okay.
This is where we need what's called a quantum classical interface.
What is that?
So it's basically a way to convert that energy that's being released from those quantum transitions into something we can actually use.
Yeah, like the electricity.
Like electricity, exactly.
Yeah.
So think of it like a translator.
Okay, yeah.
Between the quantum world and like our everyday world.
So it takes the quantum stuff and makes it like normal energy?
It takes that quantum energy and converts it into something usable.
Okay, how do we do that?
Well, one promising approach is to couple the ions to a superconducting circuit.
Superconductors, like the things that conduct electricity?
Yes, exactly.
With like no resistance.
With zero resistance.
Yeah.
They're really good at, detecting these subtle changes in energy.
Okay.
So they're a good candidate for like sensing when the ions release energy.
So they're like little antennas.
Yeah, like tiny little antennas.
That are picking up
those energy signals.
And then they turn it into...
and converting the...
electrical current.
Okay.
But, I mean, this is all...
Yeah.
Sounds very theoretical at this point.
Really complicated.
Yeah. There are a lot of technical challenges.
Okay.
Like, how do we make sure the energy transfer is efficient?
Right. Like, how do we not lose any of it? Yeah, we want to minimize energy loss, and then the whole system has to be stable. It can't just, fall apart.
Okay, but if we could do it...
Right.
How much energy?
That's the big question.
Hey, like, are we talking like...
how much power?
Powering a light bulb or like...
could we get out of this?
Powering a city.
Well, that's the thing. It's hard to say at this point because it is so theoretical.
Right.
Entangled could be huge. But the actual amount of energy, it really depends on a lot of factors.
Okay.
The particles you use, how big the system is,
yeah,
how good we are at converting the energy.
So, like, we don't know yet.
We don't know yet, no.
But it could be big.
It could be huge, yeah.
Okay, so let's say...
That's what's so exciting about it.
We can figure this out.
Yeah.
Like, could entangled actually...
Could it really?
Like, power our houses?
Power our world.
Could we, like, put it in a spaceship?
Well, think about that. Space travel, powered by entangled.
We could go anywhere.
We could go so much further.
It's amazing.
It's mind-blowing, right?
It is mind-blowing.
It would change everything.
Yeah, but we got to be realistic, too.
Of course, we have to be realistic.
Like, this is all...
We're talking about quantum mechanics.
Yeah, super early.
It's very complex.
We don't understand it that well.
Yeah, there's a lot we still don't know.
Entangled could be like...
It could be a long way off.
Decades away.
Decades, maybe even centuries.
Yeah, but even so...
But that doesn't mean...
It's worth thinking about.
We shouldn't be exploring these ideas.
Yeah, like pushing the boundaries.
Absolutely, we have to keep pushing.
Of what's possible.
The boundaries of science.
Because... like, all this stuff we have now...
we might discover.
Was crazy to think about.
Yeah, things that seemed impossible.
Right, so to our listener...
To the listener.
Who gave us this idea.
Who came up with entangled.
Thank you.
Thank you so much.
For this amazing concept.
For sharing your idea with us.
And to everyone listening.
And to everyone out there.
Keep those ideas coming.
Yeah, keep thinking. Keep exploring.
Because who knows?
Who knows?
Maybe one of you...
what the future holds.
Will change the world.
Maybe one of you will unlock the secrets of entangled.
Exactly.
And change the world.
So thanks for joining us.
It's been a pleasure.
On this deep dive into entangled.
It's been a fascinating conversation.
It really has.
Yeah.
Until next time.
Keep exploring.
Keep exploring the universe.
The universe within and all around you.
Yeah, exactly.
It's amazing out there.
Okay, so we've spent all this time talking about how entangled works, but what does it actually mean for us?
What are the implications?
Yeah, what if this idea that, like, you came up with...
It's a pretty wild idea.
Yeah, could actually change the world.
Well, if we could really make entangled work, the potential applications they're pretty incredible.
Yeah, like imagine we don't have to worry about...
energy is not a problem.
Energy anymore.
You know, a scarce resource anymore.
Yeah, like no more fossil fuels.
Right, no more pollution from fossil fuels.
I mean, like
oil spill.
It'd be a completely different world.
It would change everything.
Yeah, think about like space travel.
Oh yeah, like we could
go so much further.
Go anywhere.
If we had these like compact, super efficient entangled units
like
powering our spaceship.
Straight out of Star Trek.
Right.
Yeah, and what about computers?
Oh, yeah, computers.
Like quantum computers.
Quantum computers are already
super powerful.
On the edge, but
they have the potential.
They take so much energy.
To revolutionize so many fields.
Yeah.
But they need a ton of energy to run.
That's where entangled comes in.
Exactly. Entangled could be the key.
It could, like...
to unlocking their full potential.
Power all these amazing...
It would be a...
new era of technology.
It's pretty crazy to think about.
It is. It's exciting, but...
But we do have to, like...
We also have to... acknowledge the challenges.
Yeah, this is all still theoretical. It's a very young science. There's a lot we still don't understand.
Right. Entangled could be like...
It could be a long way off.
100 years away.
Yeah, it could be decades.
Yeah.
Maybe even centuries.
But still cool to think about.
It's still worth exploring.
Yeah, and like who knows what we'll discover.
Like the future.
It's full of possibilities.
So to our listener.
To the listener.
Who sent us this entangled idea.
Who sparked this whole conversation.
Thank you.
Thank you so much.
For like blowing our minds.
For sharing your incredible idea.
And to everyone listening. And to all our listeners.
Keep thinking about this stuff.
Yeah, keep those creative sparks flying.
Keep sending us your ideas.
Who knows what you might come up with?
Because like one of you.
You could be the one.
To change the world.
Unlock the secrets of entangled and change the world.
So, thanks for listening to another deep dive.
It's been a pleasure being here.
And we'll see you next time.
See you next time. Keep exploring.
Keep exploring.